All right. So, silly introduction aside, what I want to focus on today is we really need to get more solid on the relationship You know, all of math is really about relationships. I'm trying to get you guys ready to become young adults and the future relationships you're going to have. Because relationships need to have good rules. Relationships need to have boundaries and clear communication. You know, if I do not communicate clearly with my wife, I will not be in that relationship for very long. So everything is a relationship that we're going to talk about. And today we're talking specifically about the relationship. It's a love story, if you will, about points and lines. And it's a love story. And let's just give this a nice little pink heart to show that this is a love story. It's also lesson number 2.2 if you're playing at home. All right, lesson 2.2, the relationship between points and lines. And so everything that we do around points and lines starts with our Cartesian plane. So this is at the heart of everything we're doing. We have this guy, right? And we've drawn this thing millions and millions of times, but I really want to just take the time to kind of remind you guys what is going on here. So, our Cartesian plane is really a way of understanding a relationship. Okay? It's just a way of understanding a relationship. It's as if two number lines fell in love, right? We have a number line here. Number line. 0, 1, 2, 3, right? We've seen this a million times before, right? -3, -4, right? Number lines. And this is one number line. His name is X. And then we had another number line. Exactly the same, right? Scooby-doo-boop-doo. Looks exactly the same. 0, 1, 2, 3, -1, -2, -3. And this number line's name is Y. X and Y are these two number lines doing their own thing. And one day, they fell in love, and they had a baby. Hey, you know what? Math is love, math is life. And so what we have here is we have the XY plane. We have the XY coordinate. And this XY coordinate is the relationship between two variables, X and Y. So what we're looking at here, it's as if we took our Y number line and we just took it and plopped it on top of our X. They intersected, right? So this X is really just a number line. 1, 2, 3, 4, 5. I'm going to be very diligent about this. -2, -3, -4. It's just that same number line here. Just the same number. I just rewrote it down here. But now it's in a romantic relationship with its BFF and life partner, Y. And Y just goes 1, 2, 3, 4, -1, -2, -3, -4. And that should be good enough. Okay? And so now they are crossed forever. They are forever intersecting. And so X and Y have a couple of ways that we talk about the relationship. Every now and then they go on a date together. You know, when you go out on a date, you have a specific interaction. We're going to go to a movie. We're going to go to the ballet. We're going to go to the opera. We're going to go for a long walk on the beach. We're going to have a candlelight dinner. Okay? And so those singular moments, we call points. Points. Singular moments in the relationship. And it shows what everyone is doing at that point, right? You know, we represent it by saying X comma, y. X, comma, y. And what that means is that we are going to find on both number lines what's going on here. So for example, if I had a sample point, and I said it was, we'll say x was at 2, y was at 4. Okay? What I do is that since this is my x, I go over to 2 here, and then I go up to 4. Okay? And so that singular point is called 2, 4. Okay? That's just how we point out a singular point on our xy. I could have a different point. -2, 3. In this case, I go over -2, and I go up 1, 2, 3. And that's another point. -2, 3. All right? Does that make sense? Just kind of how we call points. This should be fairly much, pretty much just review. But what ends up happening is that we end up with more than just dates, right? It's more than just a single moment. It's more than just a single point. Sometimes what we're trying to do is we're trying to talk about the relationship between x and y as x and y change, right? Because, when I first met my wife, we were different people than we are now. We've changed over time. Our relationship is different even though we're still tied together. And that will continue in the future. So when we talk about relationships like that, what we're doing is we're talking about lines. Lines. Lines are continuous relationships. Continuous relationships. Not singular moments like a point, but a continuous relationship that goes on and on and on. And so what we normally do is we call it y equals mx plus b to talk about what is going on here. And as we all know very, very well, because we've gone over it about 500,000 times, we know that the m is slope, and we know that the b is our y-intercept. And so if I were to have a line, in this case I'll say y equals, let's say, 1/2 x minus 3. Okay? Y equals 1/2 x minus 3. I'm going to graph this boy. So I'm going to go down to 3, because that's my b. And then I'm going to go up 1 over 2. And you see how when I do this, I go directly to the corner there, up 1 over 2, up 1 over 2. And then I can go back the other way, down 1 over 2, down 1 over 2. And you can see my grid goes on and on forever. I can just continue this line, continue this pattern on and on and on and on if I wanted to. I don't want to, because that would take forever, but I could. And then I draw my line, okay? And I put arrowheads to show that this relationship is everlasting. Y will always be 1/2 of x minus 3. Okay? Whatever it is will be that. But what I want you guys to see, and this is the tricky part, is that this line is nothing except an infinite series of points. Like, I talked about these points because they're easy to go off of from the graph and the slope, right? What point is this? Well, this is the point 6, 0. And this is the point 4, -1. And this is the point 2, -2. And this is the point 0, -3. This is the point -2, -4. This is the point -4, -5. And it goes on and on. Each point has its own name, right? But what I want you guys to see is that the line is just an infinite number of points. Because let's look at this segment right here, between 0, -3 and 2, -2. Just this section right here. If we wanted to, this line is even more points. Let's look at this point right here in the middle here. Well, x is 1, And my y is, well, it's halfway between -2 and -3. So I'd say -2.5. That little point right in there has a name. And if we wanted to, we could then even go even further. Right here in the middle, right there, that's another point. This would be the point, well, it's like right here, right? So that's like 1/2. And this is like, I don't know, 2 3/4. So even this tiny little point right in here. Here, I'll zoom in. Let's zoom in. Zoom it in. Well, can you get the point? Is it clear enough that you guys kind of see what I'm saying? See like the green right in there? This little tiny point right in there, right? That's the point. Well, my x is like 0.5, and my y is like 2.75, right?
Wow.
And every single point on the line, everywhere that there is ink, we can say has a name. We can say that it's a relationship between x and y. The easy ones are, of course, these ones right here, right? These ones right here are easy to see. They're easy to calculate. You know, they're right on that intersection. They make life a lot easier to understand. But all of these, anywhere where it's blue, that's a point. And they're points that are just successively closer and closer and closer together, so that it looks like it's one thing. And in fact, it's both. It's both at the same time. It's both one thing, and it's a series of points connected. Does that make sense? You know, it's kind of like if we were standing shoulder to shoulder. We are definitely different people, but there's nothing in between us. We're the same person. We're in this class together. All right. Okay? That's exactly what's going on here. Okay, so why is this important? Why am I taking the time to go on and on and on and on about this? Because a lot of the questions that I'm asking you to do on your homework is asking they say things like, when is it true? Or is it a solution for the line, right? What I want you guys to see is that a line has an infinite number of solutions. Infinite. And so if I were to take this line and I were to ask you, is the point -4, -5 a solution? You can look at the graph and see that yes, it is. But you don't just have to look at the graph. We could look at our original equation over here. We could look at our original equation over here and see that y equals 1/2 x minus 3. And I could plug in my x and y to see if it's true. In this case, my y is -5, so I'll write that where it says y. That's going to equal 1/2 times my x, which I see is -4. And then I'm going to subtract 3 from that. Okay, so -5 equals, half of -4 is -2 minus 3. And -5, sure enough, equals -5. And so that checks out. It definitely checks out. So we can do it two ways. We can plug it in. And then so imagine instead we had some random line. Let's say this line's going to be orange. Let's say we had some random line that cut through like this. Okay? So now it's two relationships in x and y. Like this is, you know, my wife and I loving to go to dinner, and the orange line represents us liking to go to the theater. Okay? And so if we're going to the theater and going to dinner, where do you think we're going to go? Well, we're probably going to be in downtown Portland at Keller Auditorium, and we're going to go to Raven and Rose, because that's our space before we go to the opera. Okay? So this space right here represents the opera. But we can see that these two lines, these two relationships are true right here at -2, -4. They're both true at the same time there. And sure enough, if we plug -2, -4 into our orange and blue, it would come out true like this. Right? Any clarifying questions? All right, I see that a lot of you guys have become enthralled with my voice, but I'm looking over and I don't see a lot of notes down in your paper, and that's really disappointing to me. You guys need to be taking these notes. This is complicated. Math is hard, and just listening to my voice isn't going to be enough. So I'm going to go ahead and pause the recording. I'm going to leave this up here. And I want you guys, at every single table there's colors, at every single table there's markers. I want you guys to write this stuff down in a way that makes sense to you. I want you to spend a couple minutes right now making complete sense of what we just went over. Because this is life, man. This is relationships. You'll need to know this.